but I was just talking to David Eagleman, who was talking about a very simple experiment, actually. And this kind of shows how your brain is basically always interacting with the outside world and always making adjustments to make its best guess about the most useful present moment experience to deliver. So this is a very simple experiment. This is from many, many years ago. And David Eagleman was involved in this research, where they had participants hit a button, and that button caused a flash of light.
Mm-hmm.
And so our brains, through binding, the brain, it notices, is able to kind of calibrate the experience you have, because the brain is aware that it is its own hand that is causing the light to flash, that there's this cause and effect going on. And so you have this experience of pushing the button that causes the flash of light, which is true, and the light flashes. You can start to introduce longer pauses, starting with 20 milliseconds, 30 milliseconds, going up to, I think, 100, maybe even 200 milliseconds, where if you do it gradually, since your brain is making the adjustment, you can introduce a delay. I think it's up to 200 milliseconds. If you do it gradually, you will still have the experience, even though there's now a delay between when you hit the button and the light flashes. You will still have the exact same experience you had initially, which is that the light flashes right when you push the button. In your experience, nothing is changing. But then, so they gradually give a delay. You've acclimated to that because it was done gradually. If they then go back to the original instantaneous flash, your brain doesn't have time to make the adjustment, and you have the experience that the light flashed before you hit the button. And that is your true experience. It's not like you're confused, but that is, your brain didn't have time to make that adjustment. You think you're in the same environment. You're pushing the button, it makes the light flash. It's kind of calibrating all the time. But then the participants are suddenly saying, oh, wait, that was so weird. The light flashed before I hit the button. And so these
That's
types
crazy.
They built a Rochambeau, rock, paper, scissors computer game that was unbeatable based on this glitch that you can present in binding by training someone. If you introduce a delay slowly enough, then the computer can get the information before it responds, but you still have the experience that you're both throwing out your rock or paper, scissors at the same time. But in actuality, the computer saw your choice before it makes its choice. And it's in this window of milliseconds where you don't notice it.
So that starts to help you build up an intuition that this conscious experience is an illusion constructed by the brain after
conscious will.
Conscious will.
Yeah. And just in general, that consciousness is not the thing that we feel it is, which is driving the behavior. That is actually at the tail end of it. And so a lot of decision-making processes, and there are studies that are more controversial, and I don't usually like to cite them, although if you want to talk about them, we can. They're super interesting and intuition shattering. But there are now studies specifically about free will to see if there are markers at the level of the brain that can see what decision you're going to make and when you make that decision. And I think the neuroscience inevitably is just going to get better. And so